Assalamualaikum friends, welcome back to my YouTube channel. Hope so you are all doing well by the grace of Almighty Allah. Today we will come with another new topic. In this topic we are discussing about water filtration and reabsorption in the nephron. So let's start the topic. In the glomerulus, water is initially filtered out along with the other solutes, for example sodium, potassium and glucose. From here H2O needs to be reabsorbed into the tubule cells and then back into the interstitial space. From this interstitial space, water can move back into the vasa recta, the blood vessels running alongside the nephron. There are three main places where water reabsorption occurs. Number one, the proximal convoluted tubule (PCT), the descending limb of the loop of Henle, and collecting duct. These are the three main places where water reabsorption occurs. It is also very important to note that water reabsorption is heavily driven by the movement of sodium as a rule of thumb. Water tends to follow the direction that sodium moves in. You can see clearly in this picture proximal convoluted tubule, distal tubule, and the glomerulus, collecting duct, descending loop of Henle, and ascending loop of Henle. You can see in the diagram clearly. Next, proximal convoluted tubule (PCT). In the PCT, sodium is taken up from the filtrate back into the tubule by sodium-linked glucose transporters. Next, sodium movement makes the tubular intracellular fluid were more concentrated than the filtrate. This creates a concentration gradient to drive water movement into the tubule. This is also known as transcellular movement and occurs when water moves across the cell membrane via aquaporine channels driven by osmosis. Next, once in the cell, H2O molecules they move out of the cell into the cortical interstitial space via another AQP one channel on the basolateral surface. Paracellular movement of H2O occurs between tubule cells and is due to the higher hydrostatic pressure in the filtrate than in the interstitial space. This forces water between the tubule cells through the leak tight junctions. Transcellular movement of water effectively bypasses the tubule cell and moves it straight from the filtrate to the interstitial space directly by the end of the PCT, the concentration of water in the filtrate and interstitial space is almost the same. Overall, about 67% of the water filtered is reabsorbed in the PCT. Next, you can see the loop of Henle. While water reabsorption occurs in thin descending limb of the loop of Henle, it is permeable to water, which means that water molecules are freely able to leave it. Similarly to in the PCT, water can leave the thin descending limb into the more concentrated medulla through transcellular and paracellular movement. Because the thin descending limb is permeable to water, water can move out into the more concentrated medulla via osmosis. You can see the driving force behind this is the movement of sodium, potassium and calcium from the tubule to the medulla via NKCC porters in the thick ascending limb. This makes the renal medulla more concentrated, providing an osmotic gradient. Collecting duct. You can see in the collecting duct. In the collecting duct, water reabsorption is driven by antidiuretic hormone ADH. ADH is produced in the hypothalamus and is secreted from the posterior pituitary gland in response to low plasma. ADH acts on the principal cells in the collecting duct by binding to receptors. This triggers an intracellular signaling pathway that causes increased aquaporine production for the apical surface of the principal cell. The water can then move through the tubule and back into the renal medulla. Similarly to in the loop of Henle, the force driving this movement in the high concentration of Na positive in the renal medulla. This is all about the today topic. No, inshallah we will meet in the next video. In the end, I request all my friends to subscribe my channel, like my video. Thank you so much.